5-3, day 3, non-memorized trigonometric equations. This will be a recap of what we discussed yesterday. So here's the picture. If a positive ratio is used when you do tan inverse, sine inverse, or cosine inverse, then the answer you get will always be a first quadrant beta value, or x value in this case. So if you need something in the second quadrant, since this is pi, this would be pi minus your answer. A third quadrant answer would be pi plus your answer. And a fourth quadrant would be 2 pi, because this is 2 pi, minus your answer. And that's building on the fact that each of the quadrants is sort of a reflection, either over the y-axis or over the x-axis, of something in the first quadrant. If by chance you need to use your answer more than once, we talked about the fact that you could store your answer in any of the alpha characters on your calculator. Okay, so let's try some problems. 5 cosine theta minus 3 equals 0. First we do the algebra. So we get to cosine x equals 3/5. 3/5 is not a memorized ratio for cosine. So we're going to do cosine inverse of 3/5, and that will give us x, in this case theta. And then that will be a first quadrant answer. But we also know that cosine is positive in the fourth quadrant, so we will also need 2 pi minus our answer. So let's go out and get those. So inverse cosine of 3/5. Okay, so 0.927. And we also need 2 pi minus our answer. And I didn't need to store that one because I'm only going to use it once. So 5.356. So let's go write those down. Approximately 0.927 and approximately 5.356. 12 sine x plus 7 equals 0. So we will get to sine x equals negative 7/12. And technically what we need is sine inverse of negative 7/12. But in order to use a system that is really simple, I'm going to find sine inverse of positive 7/12, and I'm going to store that because the real answers I want are where sine is negative. So a third quadrant and a fourth quadrant answer. So I'm going to need pi plus my stored answer, and I'm going to need 2 pi minus my stored answer. Okay, so let's go do this. So I need sine inverse of positive 7/12. And I'm going to store this in alpha A. Okay, so then I need pi plus my stored A, right? So pi plus alpha A. And I also need 2 pi minus my alpha A. So 3.764 and 5.660. 3.764 and 5.660. Let's try one more. So now we have a trinomial. We have a tan squared x plus 5 tan x minus 14. None of them like terms. 3 terms. Again, what we did with these, if we were having a little trouble, is you could take the trig out, x squared plus 5x minus 14, and factor that, because sometimes it's easier to see it without the trig, and then come back and put the trig in. So this is tan x plus 7 with tan x minus 2. So we've got tan x plus 7 equals 0, or tan x minus 2 equals 0. So we have tan x equals negative 7, or tan x equals 2. Okay, so tangent is positive here and here, negative here and here. So for this one, I'm going to need tan inverse of 7, and I'm going to store that. Because what I'm going to need is pi minus my answer and 2 pi minus my answer. For this one, I'm going to be able to do tan inverse of 2, and that will be one of my answers. And I will also need pi plus that answer. Okay, so let's go over and grab a whole lot of stuff. So we need tan inverse of 7, and I'm going to store that in alpha A. So what I want is pi minus my answer. Oops. Oh, actually I want pi minus what I've stored in alpha A. That's better. And I need 2 pi minus what I've stored. Okay, so I have 1.713 and 4.854. .713 and 4.854. And for the other problem, inverse tan of 2. That's one of my answers, 1.107, and pi, let's see, I want to be in the third quadrant, pi plus my answer, 4.249. So approximately 1.107 and 4.249. Okay.